Assalamualaikum and good morning. I am Dr. Nafarisa. So today we'll go through a topic in chemical engineering basic principles and calculation, which is introduction to reactive and non-reactive system. So in this topic, students should be able to understand the non-reactive and reactive system. Understanding this distinction is very important because it directly affects how we design, operate, and ensure the safety of chemical process. Let's start with non-reactive system. A non-reactive system is one where no chemical reaction takes place. Instead, only physical changes occur, such as phase changes, mixing, or transport of materials. Some example you might already be familiar with is distillation, like separating ethanol and water, or absorption, such as removing carbon dioxide from gas stream, or crystallization, like producing sugar crystal, by which we separate the liquid and the sugar, or simply heat exchanger, where we transfer energy between hot and cold fluid without changing their chemical identity. So the key thing to remember here is that the molecules remain chemically the same. What changes are just their phase, concentration, or temperature. Because of that, non-reactive systems are often simpler to model since we don't need to worry about reaction kinetics. Now let's take a look at the example on non-reactive system. Okay, for example, separation of fresh juice, for example, orange juice into solid and water using evaporator. Okay, now we have the incoming stream, which is M1, having 1,000 kilogram per hour of juice, which having 7.08% solid. So through the evaporator process, we separate water, which is M2 stream, which only contain water. There's no solid in M2 stream. And lastly is M3 stream, which is a concentrated juice. So in this M3 stream, is have solid as well as water. So 58% solid and the rest is the water. So how can we solve this non-reactive system? Okay, non-reactive system only involving the um, species, separating of the species in this case. So there's no reaction involved. So then we can solve it by using the total valence, by which we know that the inlet equivalent to outlet. The inlet is M1 and the outlet is M2 plus M3. And we are given the amount of M1, which is 1000 kg per hour of the juice. Okay, and M2 and M3 remain unknown. And now we do the solid balance. Okay, in the incoming stream M1, we have 7.08% of solid. So 0.708% is actually 0.0708 M1. This is solid incoming. M2 there's no solid, and M3 we have 58% of the solid. Okay, this is how we express the equation. And from this equation, I call it as equation 2, we can solve for M3. Okay, so M3 end up with 122.06 kilogram per hour. This is the concentrated juice flow rate, mass flow rate. Now, since we already solved for M3, then we can substitute this M3 into equation 1, then we can solve for M2. So, at the end of our calculation, we solve for M2, which is only contain water, 877.93 kilogram per hour. So from this example of non-reactive system, uh, the process actually conserves the total number of mole for each species. In this case, solid and water. Okay, so the it only governed by mass transfer, heat transfer, and fluid dynamics. Now let's contrast that with reactive system. In reactive system, chemical reactions occur, which means new substance with new properties are formed. Okay, it's no longer the same as previous one. So in reactive system, things the chemical change due to the reaction. For example, in combustion we have a fuel react with the oxygen. At the end of the day, it produces carbon dioxide and water. Okay, let's take a look at this example of the combustion. We have methane, 100 mole of methane, and then we have another inlet stream and one which is oxygen, and we have outlet stream N2 containing CO2 mole, N2 mole of carbon dioxide, and N3 mole of water. So for a complete combustion, we have CO2 and water as the product. For a reactive system, we can solve it by atomic balance. So this is one of the method to solve. There are a few others, but today we'll solve using atomic balance. So we have methane, CH4, and we also have carbon dioxide, CO2, we have oxygen, O, and we would also have water, H2O. So meaning we have carbon, hydrogen, and oxygen balance. So let's start with the C balance, the carbon balance. We know that the incoming C is coming from the methane, 100 mole of methane. The outlet of C is from the N2 stream, N2 mole CO2. In 1 mole of CO2, there is 1 mole of carbon. Then we solve this one, we get N2 equal to 100 mole. Now let's solve for H balance. So for H balance, we have methane. We do have H atom in the methane and in the water molecule. So we equate the inlet and outlet, 100 mole of methane. In 1 mole of methane, there are 4 mole of hydrogen atom, and 3 mole of hydrogen. In 1 mole of hydrogen, there are 2 mole of. In 1 mole of water, there are 2 mole of hydrogen atom. And then we solve for the N3, we end up with the N3 is 200 mole of water. So you can do the oxygen balance by yourself. Okay, for this reactive system, it involves the reaction kinetics. Okay, that is a reaction equation. For example, A plus B equal to C. So overall, the chemical engineering process can be grouped into non-reactive and reactive. Non-reactive involve only physical transformation, by which um, reactive system involve the chemical transformation into a new product. By understanding this reactive and non-reactive system, we can use the information for process design, safety, and efficiency. So that's all for today. Thank you.